there. In this course, you'll be learning how to communicate with a database by using a language called SQL or SQL. SQL stands for Structured Query Language. The way I see it, the proper way to learn SQL is a bit like learning how to drive a car. You learn by far the most by actually getting behind the wheel and driving the car, not by reading some book about it in theory. If you're a business user with no or limited IT skills, then you are exactly the audience I designed this course for. I will start by giving you a basic idea about SQL before you start writing some code. I will be explaining a lot through SQL code, so I encourage you to participate actively. Don't treat this course as a lecture. I'm more like a buddy sitting next to you, showing and explaining things while you type. As you make progress, I will gradually introduce you to small bits of theory which you need to know to actually solve the exercises. Now, before we get started, a few words about myself. My name is Jonas. I have a bachelor's degree in Business Information Technology from the University of Applied Science in Bern, Switzerland. I have over 10 years of experience with SQL and have worked in both the business and IT side of a company, so it comes quite naturally to me to see things from both perspectives. This course follows the 80-20 principle. In other words, I will teach the 20% of SQL you'll need to be able to solve 80% of the challenges you encounter. These 20% is the result of pretty much all the SQL fundamentals, techniques, and best practices I have acquired in the past 10 years on the job. They are basically my building blocks when writing SQL queries, and I still use them on a daily basis. I will now give you a very short introduction to SQL fundamentals so that you get the basic idea. SQL is not like a search engine like Google, where you type some words and it tries to find the best matching results. In SQL, you have to give precise instructions on what you want to see and don't want to see in a predefined and structured way. SQL is divided into 5 different areas. The focus of this course is on DQL, the data query language, because as a business user, you'll be using this in 99% of your time. The reason is that in the real world, you will most likely be working for a company which already has been using a database for many years. So it's unrealistic that you will be designing a database from scratch. Furthermore, IT and compliance normally have strict rules on permissions and data integrity, so it's unlikely that you will be allowed to manipulate data freely. So as a business user, you will most likely have read-only access to the data anyways, and this is covered by DQL, the data query language. SQL has been around since the 1970s, so it's pretty safe to say that pretty much every thinkable SQL problem has been solved by someone in the world in the past and present. In other words, you don't have to reinvent the wheel when writing SQL queries. Use platforms like Stack Overflow, or ask your work colleagues when you're stuck with your query. The relational database we will be using in this course is Oracle SQL, but there are many more. The most popular are Oracle, MySQL, PostgreSQL, Microsoft SQL Server, and so on, and they are all a bit different. But no need to worry, the difference isn't like English and Chinese. View it more like how American English and British English are dialects of English. So an American might say chips, while a British would say crisps, or gas station versus petrol station, or sidewalk versus pavement, and so on. Both languages still share the same grammar rules and vocabulary. This is how you should see the varieties of SQL. They are actually more similar than they are different. A database can have many schemas. We only have one called admin, which is also the name of the user. In every schema, you have multiple tables which are somewhat connected to each other. That's why you call them relational tables. Now, I'm pretty sure that you can somewhat comprehend this, but without really understanding the meaning of it all. As soon as you use Excel as a memory hook, this information becomes a bit more digestible. Imagine that you have a folder on OneDrive or SharePoint called Oracle Free Cloud. You need to request permission to access it, so you can imagine that this is your database. In that folder, you have an Excel file called admin, and in there are sheets called content, content types, and so on, with data in them. A schema is not much different. It acts as a container for tables and other things. So when you're in SQL Developer, You can actually look at it like this. Table content is like a sheet in Excel, highlighted red. The column names, highlighted green, are arranged like this in SQL Developer. Now, if you can remember, the first SQL statement you wrote was select star from content usage. The select part controls which columns you want to see. The star is a shortcut for all columns. The from part controls which table you want to read from. Now, SQL is quite strict when it comes to the structure of a SQL statement, so you can't do it the other way around, like from content usage select star, you will get an error message. This should look a bit familiar to you because in Excel, you do these kinds of aggregations with the pivot feature. In pivot, you have these kind of aggregations in the bottom right box called values. Now, if you want to do these aggregations for every user separately, then it's not enough to add user ID in the select part. You have to use the keyword group by and add the columns there. In Excel, it would be like adding user ID at the rows section. Let's do this now in SQL Developer. First of all, let's remove the min, max, and average. We won't be needing them. We only want to know how many times a user has paid and how much in total. Now let's add user ID and a comma for count. Like I mentioned, SQL will refuse to execute this query because it's missing something. What we need to do is add the keyword group by and the column name, which is not an aggregation. This would be user ID. If you want to understand an inner join, then it's easier to understand it when you look at it like this. Your query will only show what's in both tables, which is highlighted red. In this case, only A, B, C, D appears in both tables. The rest will be ignored. There are other types of joins as well. The left join shows the same thing as inner join, but it also shows the data which is only available in table 1. And then you, of course, have the opposite, the right join. This one is also the same as inner join, but also shows the data which is only available in table 2. Now you'll be learning, in my opinion, one of the most important techniques of the entire course. I use this every single day at work, and it has always been crucial in solving very complex problems. It will allow you to really work in a divide and conquer approach. So let's look at a problem first. We want to know how many unique devices there are per user. The place to find this information would be in the content usage table. So it's not the IP address, it's the MAC address we're looking for. For now, let's just check how many unique devices there are for only one user. Let's take user ID 1. You can pause the video here and try it yourself first. The solution is to add the keyword distinct to the select part. This will ensure that we won't see duplicates. And at the bottom, we just add the where clause user ID equals 1. Okay, so user ID 1 has 4 devices. Let's write this up as a comment. So I'll press minus minus, white space, and user ID equals 1, 4 devices. Now let's count how many MAC addresses this user has to see if we also get 4. Pause the video here and try it yourself. So let's put a count on MAC address and call it dev CNT. Oops, I forgot the group by. We have to group by user ID. 135 is definitely not the number we were expecting. So the problem is that we're trying to mash 2 separate parts into one. At the moment, the query is counting all MAC addresses of this user first, which is 135. So the query is not doing what we want it to do. So this is the moment where you need to divide and conquer. If you analyze it, there are actually 2 different steps we need to do. First, do a distinct select on user ID and MAC address. Second, count MAC address on top of this distinct select. So first, let's write that select distinct query again, so we can delete the group by part and the count. We don't need that anymore. Now we're going to wrap something around this query called a with clause. So above this query, we type with, and let's call it user devices. Now you write as and open a bracket and close the bracket. Let's use the tab key to make it more readable. At the bottom, you write select star from user devices. I'll now use Excel to explain what's happening. So what we're doing is like opening Excel, but without saving the file. It's just temporarily there and disappears after you execute the query. So it's a bit like creating a sheet called user devices and saving the result of the query, the blue part, in there. So at the bottom, we can just treat this sheet as a table and do a select query on it. In SQL, you call this a CTE, which stands for Common Table Expression. There's basically no limit on how many CTEs you're allowed to have in one SQL statement. Professionally, I normally use around 3 to 7 CTEs in rather complex queries. So do you see the potential here with this technique? Like I already mentioned, by using the divide and conquer approach, you can split your complex problem into different CTEs. They are like your Lego pieces. And in the end, you can use joins, group bys, and whatever techniques you need to get the results you need. Now that you get the basic idea, you can pause the video and try to finish the query. Remember that we want to see how many unique devices a user has. So we want user ID and